Okay, the last thing we're going to add in are x, y intercepts and actually graph these rational functions. So the steps of what we want to do is factor our numerator and denominator. So if we look at this first one, we've got x plus 3 over, multiplies to be 15, adds to be 8, would be x plus 3, x plus 5. Want to state our domain. Things that make my denominator 0 are negative 3 and negative 5. Negative 5 is smaller, so we're going to go negative infinity to negative 5, union negative 5 to negative 3, union negative 3 to infinity. Vertical asymptotes, horizontal asymptotes, and wholes. Okay, remember vertical asymptotes and wholes we find from the denominator. So x plus 3 and x plus 3 cancel out. That makes this a whole, so we'll have negative 3. We'll fill that in a second. Left over is x plus 5, so that negative 5 is a vertical asymptote. X equals negative 5. I'm going to go ahead and finish my whole. When we look at this, we want to see what's left over. We've canceled everything on the top, so we'll have 1 over, hold its place, x plus 5. So when we find the y value of my whole, remember we plug into the simplified form, so this would be 1 over negative 3 plus 5, which is 1 over 2, so 1/2. Horizontal asymptotes, we look at our exponents. So we've got x to the first over x squared. The bottom is bigger, so we got a big bottom, which would be at y equals 0. Now, to find the x-intercepts. So x-intercepts are at something comma 0. So something comma 0 is what we're going to plug into. We're going to set the numerator, this is the simplified, and the simplified equal to 0. So when we look at it, my simplified is 1 over x plus 5. We set the numerator equal to 0, that would be 0 equals 1, which does not make any sense at all. So in actuality, we do not have an x-intercept. No x-intercept. My y-intercept, we're going to plug 0 in for x on the simplified equation. So this is going to be in the form 0 comma y, so 0 comma something. So when we plug it into my simplified in for x, we'll have 1 over 0 plus 5, which is just 1 over 5, or 1/5, which is 0.2. So now we want to go through and we want to graph everything. It tells us to pay attention to the parent function of the simplified equation. That's going to tell us what our graph will look like. It'll either be irrational, quadratic, or linear, the ones that we're going to deal with. So if we look at my simplified, this is 1 over x plus 5. So this is going to be a rational function. So it's going to have our 2 graph pieces. So we're just going to graph everything we see. Vertical asymptote at negative 5. Horizontal asymptote at y equals 0. We have a whole at negative 3, 1/2, so I'm just going to draw in my whole. We don't have an x-intercept, which we've got this horizontal asymptote, which kind of helps us see that. A y-intercept at 0, 1/5. So 0.2, so we're really close to the y-axis. Knowing the parent function, which looks like this, we're going to use that idea to help us sketch this. So we're going to go from here, it'll keep approaching 0, and then it's going to turn up. My bottom one is going to do much the same thing. If this one stays pretty close, then kind of, you're basically just sketching its reflection that direction. So there you have the graph of x plus 3 over x squared plus 8x plus 15. Looks like your basic 1 over x plus 5, but it's undefined at negative 3, 1/2, because we have a whole there. Okay, so same thing for example 2. First thing we're going to do is factor. I'm going to pull out the 3x. I'll be left with x plus 3 over x plus 3. X plus 3's will cancel. So domain, things that make my denominator 0 would be negative 3. It canceled, so we know eventually that will be a whole. So my domain, negative infinity to negative 3, union negative 3 to infinity. Vertical asymptotes would be the leftovers. I don't have anything left over, so I don't have a vertical asymptote. Horizontal asymptote, we've got a top is bigger, so when my top is bigger, I don't have any horizontal asymptotes either. Wholes, here we crossed out x plus 3, so we have a whole at negative 3. We're going to plug into our simplified form, so if you notice simplify, it's equal to 3x, so it would be 3 times negative 3, which is negative 9. So we have a hole at negative 3, negative 9. X-intercept, we're going to set the numerator equal to 0. So this is on my simplified. So remember, my simplified is 3x, which is like 3x over 1. So here we'll say 3x equals 0. That means that x equals 0. So we're going to have the point 0, 0. Y-intercept, we're going to plug 0 in for x on my simplified. So we're going to have 3 times 0 equals y. So y equals 0. So again, we'll have the point 0, 0. Okay, realizing what my graph is going to look like. If we look at my simplified, we just have y equals 3x, which that would just be a linear. So we know my graph is going to look like a line. So we're going to plot everything we have. No vertical asymptotes, no horizontal asymptotes, a hole at negative 3, negative 9. We'll have a hole. X-intercept at 0, 0, y-intercept at 0, 0. Knowing that this is linear lets us know that, hey, this is just the line 3x, so our slope is 3, up 3 over 1, up 3 over 1, up 3 over 1. We just happen to have a hole here at negative 3. Oops. So, when you have 3x squared plus 9x over x plus 3, this is really just graphing a line that has a hole at negative 3, negative 9. We saw that from our simplified form.